struct point, and then you just say, well, float x, float y, end of the struct, and instead of doing this, we just say, well, the x value is p.x. Or if we want to make a point, we just say struct point p, I hope you can read that, and you just say p.x equals 5. Why don't we do that when we talk about objects? Well, the thing is, once we have a struct, and we say this struct dot x, we are now bound to the fact by the language itself that this x exists in this struct here. For this we don't know what it is, yet it still provides us with the same functionality. We can still get the x out of it, but we don't care how this is encoded. For this we don't care about the data type, we can put anything in. File descriptors, for example, are just numbers, but technically speaking, again, the operating system might create a table of the file descriptor numbers. This should be a 3. And some data is going to be added to here. But to the user, the file descriptor is just an integer, and the integer will not tell the system or your program what's inside of here. That's the operating system's part. So therefore, you have some kind of security barrier between these, so that you can provide a safe and secure barrier that protects you from misuse of the data. For example, if I say, well, every point that I use should have the same distance to the 0 point, which is going to be important later on when you do some kind of mathematical calculations, which might happen to some of you, not to all, thankfully, but maybe to some. And if all of these should be the same distance from the center, and if you now have the opportunity to just fiddle around inside of these numbers, if you just say, well, p.x plus equals 10, and you just shoot that point off in this direction to here, and the distance is bigger, you can do that in C code, because you can just modify these structs. If you have functions, functions can do everything. You can, for example, check, so this is just a get function, of course, you need a set function, which works the same way. Point set x of p, and then you can say, for example, 55. You know what I mean, right? So instead of assigning it directly, we send it through a function, which basically does exactly the assignment behind the scenes. We don't know what it is, but it does it, somehow. But in this function, we can now add code. I'm just going to expand on that real quick. We can now say, well, if let's use a value like float x. We can say, well, if x is greater than maybe 50, we can then do some kind of print an error. Print an error of too big. The number is too big. And otherwise, if this doesn't happen, we can just say, okay, p.x equals x in here. So as you can see, we can now add behavior to these. The C language here doesn't provide us with a functionality of adding behavior every time we modify an object. Here we can. And this is extremely powerful because, let's say if I wanted to remove that or call these A and B, we would have to go to every single place where these are used and change these. We can't do that for big projects. For these, we can say, well, point set x, but technically what I mean is point.a, and then we write just another function, it's called point set a, which does the exact same thing. And then even the old code using this function will not break, because it's a function, it can just be called on that, and it will automatically do whatever it should do. So you can change the entire behavior of assigning, setting data values, and so on these objects. And this is extremely cool when you want to do something like when you have a lot of segmentation faults in your code. This usually happens, especially to beginners, because they have an off by 1 error. So they have an array of, let's say, 5 values or 4 values, and they want to index this value here that actually doesn't really exist. So this is some kind of value that they can't access. So you have value 0, 1, 2, and 3, and now they say, well, this is our array at index 4 equals some kind of value. and boom, there we go, we can access that segmentation fault. You're not going to detect that. I mean, you can if you have a debugger, but this can get frustrating if there's some kind of condition that doesn't give you a segmentation fault. So you're just going to write off into some kind of allocated memory here that doesn't particularly belong to this object, but you can still write into it because C doesn't have in its core protection mechanisms to like check if you're out of bounds. Again, just to clarify, C will not tell you when you are out of bounds. It will allow you to just fiddle inside of every piece of memory, just some sections are guarded with segmentation faults and some are not. If you, by chance, happen to access this data because you chose a wrong index and skip over the segmentation faulty area here, you could put a value into a data block that doesn't really belong to this array. And then you are in for a pretty happy night of debugging, I tell you. So the idea is to do something like this. Represent arrays that are important to you as some kind of object. And then whenever you want to access the array, for example by using the array underscore at function, which takes the array at the beginning, like let's stick to this naming convention, and then for, what this will do is this function is now going to do the exact same thing as this one, but it can give you an error just like this if you're out of bounds of the array. But when you create the array with a constructor function again, which is make array of type int, for example, and you want, let's say, 4 integers, it might store this number somewhere in this object. We don't care where exactly, but when we want to access it, it still knows this number. And if it sees that, well, it's for slots here, but we're accessing slot number 5, again, 0 indexing, so it's slot number 5 here, then the system will notice that and print you an error message, throw errors into your face right when the error happens, so that they don't get on unnoticed. Because this error, you might not detect immediately. You might detect that when you use that block of data, but when you write into it, you're not going to detect that. In this case, you're definitely going to see when the error happens, why it happens, how it happens. And nowadays, compilers are so good that if this function is as small as this one, this is not going to be a function call. So don't really. So my approach is not caring too much about the cost of calling these functions, because I've heard many people say, oh, calling a function is so. Like, functions are so big entities and calling them is too complicated. No, just do it. The compilers today are so good that this works exactly like this, and no performance penalty. The only thing you gain from it is you get the errors in the right spot. And with this technique, you are pretty fit for almost every programming task, because you can extend object functionality and you don't have to update every single reference to some data inside of your object when needed. This is amazingly cool for more complex programs. And for file descriptors, you can see the use, because if you tell the file descriptor for standard input to read, then it reads from the terminal. If you read from a file, it will read from a file. The operating system decides what to do, so there might be an if condition in here. If it's the terminal, read from the terminal. If it's a file, read from the file. But it works exactly the same way for the user, or for the programmer, who's actually the user of the library. So what I mean by that is objects can perform complexity while still keeping a simple interface. Here's complexity, here's simplicity, and if you use an object, you're using the simplicity side. If you implement an object, like writing this code, you have access to the more complex part of it, how it's actually implemented. So you separate the usage from the actual implementation. And if you separate them, you can change this one without that one having to change that one as well. So you can decouple them. And therefore it's easier to publish, distribute software without crashes. Okay, this is the end of the first part of the lecture. I'm now going to have a quick break, like 2 minutes, with questions if you have them, and then we're going to get on with a few useful objects, how to write them, and how they're being used. Okay?
Sounds good.
Short break.
Anyone wants coffee?
Oh,
Dann gibt es die erste Stunde über Eco.
Ich wollte erst noch eine Lecture über Lisp machen und dann.
Eco.
Später. Es wird jetzt alles aufgezeichnet. Ich will das Geheimnis behalten.
Ich spoilere nichts.
okay. Interessant.
Vor allen Dingen muss man damit noch ein bisschen warten, bis die meisten von den ersten C-Schritten weiter sind, bis man erstmal das so.
Ja, das, auf jeden Fall.
Aber du siehst, ich spanne hier gerade schon so ein bisschen
Ja.
den Bogen.
Also du erklärst gleich, wie man Objekte deklariert und nutzt.
Genau. Oder wie man C dazu bringt, objektorientiert zu sein.
Also wie man sich selber dazu bringt, objektorientiert auch zu schreiben.
Ganz genau.
Schreibst du heutzutage noch Funktionen ohne Objekte?
Ja, ganz ehrlich, ich schreibe sehr selten Funktionen ohne Objekte. Fast alles, was ich mache, ist heutzutage objektorientiert. Also ich schreibe sehr selten C++-Code.
Ja.
Aber, also ich schreibe wirklich fast alle meine Projekte ausschließlich in C. Das Problem ist nur, dadurch, dass C nicht per se objektorientiert ist, habe ich mir jetzt selber meinen eigenen Stil entwickelt, der quasi objektorientiert ist, für den ich jetzt hier bei. Und der hat mir sehr geholfen, weil meine Debug-Zeit ist vielleicht für ein Projekt von 10.000 Zeilen oder so, was ich durchaus mal geschrieben habe, ist die Debug-Zeit vielleicht 5% der gesamten Schreibzeit davon. Und für normale Leute, in Anführungsstrichen, die gerade damit anfangen, mit Objekten zu denken, für die ist die Debug-Zeit vorher gewesen, das doppelt oder dreifach. Also man kann wirklich auf 5 Minuten auf eine Stunde coden oder so runterrechnen. Also 5 Minuten Debuggen auf eine Stunde coden. Ja, so. Und das ist dann auf jeden Fall ganz einfach. Wenn man es richtig macht. Deswegen versuche ich immer so ein bisschen den Grundboden zu ziehen.
Objekt hat ja den Vorteil, dass ich halt deklariere, was es ist und somit kann es nachher alles sein.
Genau, richtig. Das ist ja das, was ich hier mache. Also das kann alles sein. Du musst den Typ ja, du musst schon einen Typ angeben, das sagt dir C, aber technisch gesehen, der Typ hier, ich meine, du benutzt ein Int für ein Datei